Alright, there, another lesson on statistics, exercise 7e. We'll look at probability density functions when they're split into two parts. You can see this from the graph here. We've got this graph part here, which is obviously a straight line going up here. But at some point, well, at 3, it changes. And we're going to do things similar to that with probability density function. Actually, this can't be a probability density function, because I don't think this area, if you had worked it out, would be equal to 1. And of course, for PDFs, the f of x is, if you integrate it with respect to x, has to always got to equal 1 between the start and the end points. So this isn't one of those, but we're going to do something very similar, which for ones which are. So be aware then that this is what I mean by it's in two parts. You'll notice it's not just one formula now. It's 0.3x between 0 and 1. So what would that look like? Between 0 and 1 it goes kind of 0.3x. So it's a straight line doing that, okay? After that, once it gets to 1, it goes to 2, and it goes to 3. It's got some other kind of gradient. And I don't know whether it's a bigger gradient or a shallower gradient. I'm just going to assume it's a bit less, but it could be a bit more. And then eventually you get up to 3. Before that it's 0. After that it's 0. And this is my kx part, and this would be my 0.3x part. And I honestly don't know what it would be. You'd have to do integration. You could be asked to do a number of things. You could be asked to sketch it, kind of like I've done. And the mean, the variance, the median, the quartiles, probabilities, and also CDF. And don't be surprised, we're going to see a lot of these CDFs today. Remember, they're cumulative distribution functions. So here's an example, and the first one is, it says find the cumulative distribution function. Now you should recall that to find the cumulative distribution function, you take your lowest value, and you go up to x, and you integrate f of x. And I'm going to do that here. Now, interestingly, there's two different formulas. One's a simple one, it's just a half, but the other one's x over 2. So I have to do it in two bits. I'm going to go from 0 to x of the first bit, which is x over 2. And I'm going to add a power. I'm going to divide by that power between 0 and x. And if I put 0 and x in, I get x squared over 4. And 0 is great, because if you put 0 in, you get 0 out. So that's the answer. Now, I actually need to do a bit more than that, because what I need to do is to see how far of the probability I've got through already. Do you remember that probabilities always add up to 1? And what I'm looking to see is how far, for instance, has the median point gone already? Am I past a half? Doesn't ask me on this question to do things like that, but you know, I could get that. So what I do is, to get that, I take the end point of my interval, and I write when x equals 1, x squared over 4, what's this equal to? Well, 1 over 4, when x is 1. And so the answer is, I'm not more than a quarter of the way through it. In fact, remember, in total it goes up to 1, so I've got a fair bit to go, and that fair bit to go must imply that this is the biggest section. Okay, so I'm now going to integrate from its lowest point up to x of the f of x, which is now changed. It's now just a half, so I might as well write a half dx. And if I do this, I get x over 2 when I add a power and divide by the power between 1 and x. So when I put x in, I get x over 2, obviously. But if I put 1 in, I get a half, so minus a half, because you take one out from the other. And that would be the answer, apart from it ignores the fact that I've already taken care of a quarter in the first section. Remember, these are meant to be what we call in CDFs cumulative distribution functions. You add up as you go along. And so if I'm going to write f of x, I'm just going to write, therefore, it's x over 2 minus a half, but I have to add on this quarter here, which is easy to forget to do. So it's x over 2, what's that? Minus a half plus a quarter is minus a quarter. So I end up now with my capital f of x. Remember, the CDF is always written with a capital, as opposed to the PDF, which is always written with a lowercase. So my capital F of x is now just remember a few things from yesterday, or the last lesson you saw. You basically always start at 0 and you always end up with 1. So in between, you've got to put your answers. Now, we've got 2 sections, so we're going to have 2 sections here as well. My first section will be my first answer, x squared over 4. And my second section will be my second answer, which is this one. It's not just this one, which is the x over 2 minus a half. I've got to take into account that quarter, which I mentioned before. So that is important as well. So my answer here will be x over 2 minus a quarter. I also need my limit. So the middle two are the easy ones. So this one's between 0 and 1. This one's between 1 and they're equal to on that side, aren't they? 2.5s. And so this one is, well, it's got to be lower than 1. So x is less than or equal to 0. And this one is x is greater than 2.5. And it can't be equal because it was already equal there. And that's my answer. So remember 0 and 1, top and bottom. Put your 2 answers in. They look right. And I even wrote there because it's easy to get these wrong. So I've checked it. That's right. Next question. Find the CDF. So exactly the same thing initially. So to find the CDF, I'm going to write integral from the lowest point up to x. It's always x, which seems weird at first. And after a while, I think, all right, fair enough. Of x over 6 dx, the first formula is what I integrate. And I integrate that, I get x squared over 12 out of the power divided by the power between 0 and x. And if I put x in, obviously I get x squared over 12. If I put 0 in, I get 0. So it's just x squared over 12. Don't forget what we did last time, which was to take our top of our interval. When x is 2, I sub that in. So when x is 2, x squared over 12 is 4 over 12, which is a third. So that tells me in this first section, remember what I said before, the probability of these things has to add up to 1. And then what I've worked out is a third of it is already gone. A third of it is already gone. But that implies there's 2/3 of it in this second section, which is now what I'm going to find the formula for. So the integral, take the lowest value, from 2 up to x, of your formula, which is now a half minus a 12th x dx. When I integrate it and add a power divided by the new power, I get x over 2 minus, I reckon, x squared over 24 between 2 and x. And when I do that, what do I get? Well, I obviously get x over 2 minus x squared over 24. And if I put the 2 in, 2 over 2 is 1, and 2 squared is 4, divided by 24 is a sixth, which I think is x over 2 minus x squared over 24 minus 5/6. That sounds right. Now, that's not the end of the story. Do you remember what we did last time? We used that number we got up here, how much is already gone, and because it's a CDF I'm trying to find, I have to write x over 2 minus x squared over 24 minus the 5/6 plus the third. Don't forget that, really important. A lot of people miss it out, so try not to. So that's x over 2 minus x squared over 24. And I reckon it's minus a half. There's my answer. So, well, not quite actually, is it? Capital F of x equals, I need to do my curly brackety thing. So start 0 at the top, 1 at the bottom. First answer was x squared over 12. Second answer was x over 2 minus x squared over 24. And don't get confused, it's not this one. It's the one you added to. It's this one here. Minus half. That was a 24 as well. Don't forget your limits. Put the middle two in first, probably easier. Just realise that was probably meant to be a equal to there, so I shall make it an equal to, even if it wasn't, who cares. This one has got to be more than or equal to 6, and this has got to be x is less than 0. So make sure you get those right. Now, what's the median of f of x? Now, the lovely thing about this is, having found the f of x, find the section you think it's in. Now, the median, of course, in the past we've done, to find the median, we've integrated f of x. And we've set it equal to half, because the median is halfway through the data. Now, this is a half still, but I've got to work out which section. It could be this section or this section I'm going to integrate. This is the great thing about this, is I've already integrated, so I can use these, just need to use the right one. Now, I know that on this one, I'd only got up to a third. So I did say that the halfway point has got to be in this section. So effectively, I can say, therefore, that formula, x over 2 minus x squared over 24 minus a half, that has already been integrated, so therefore I can set it equal to a half. And I've got effectively got a quadratic equation looking at it. I'm going to times everything by 24, make it a lot easier. 12x minus x squared. Well, move that over there, that makes it a whole one. Times by the 24 equals 24. Or said differently, x squared minus 12x plus 24 equals 0. So I'm going to solve that now. I'm going to type it in. So menu polynomial equation thingamajiggy, degree 2. So I've got 1x squared, I've got negative 12, and I've got 24. Well, 6 plus 2 root 3, you can get answers out of range. That's 9.46, that's too big. My next answer is 6 minus 2 root 3, which sounds a lot better to me. This says effectively x equals 2.54. I think that's probably right. That's right. Oh, I only gave 1 dp, 2.54, but yes, that's right. Hopefully that makes sense. Now the next question asks me exactly the same thing, apart from it says sketch the function. I haven't got time for that, I'm running out of time. So here is the function. Now let's use that. Now it says find the value of k. Now remember, the probability equals 1, so that's usually the trick we use for this, but we've got two parts this time. We've got to integrate k sine x dx between 0 and pi by 2. Yeah, that's fine. But then we have to add to it the integral from pi by 2 up to 5 pi by 8 of, what is it, k cos 4x dx. And that is what equals 1. So this, if you do it, is minus k cos x between 0 and pi by 2 plus, what's this? This gives me k over 4 sine 4x between pi by 2 and 5 pi by 8. So I need to chuck those in. Pi by 2 is 90 degrees, so if I put that into cos, I get 0. But if I put 0 into cos, I get minus k there. So that's my first answer. Plus, yeah, so if I put 5 pi by 8 into there, I get 1, so that's k over 4. Just check these on your calculator to make sure. And if I put pi by 2 into 4, remember you're timesing these values by 4, so I get 0 when I do that. So minus 0 equals 1. So this gives me effectively k plus k over 4 equals 1, which is 5k over 4, which is therefore equal to 1, sorry, which therefore implies that k does equal 4/5. So I agree with that. And I've got this last section. Now for this I need to integrate again. Well, I might as well just be aware then that what this tells me is the probability of less than or equal 11 pi by 20. Where does that fall? And if you think about it, 11 pi by 20 is a little bit more than a half. So I know already from what I've just calculated, I know that this section, when I did it, gave me an area of k. And k, of course, is 4/5. So if you like, that's 4/5 for that section. And what I'm really trying to do really is now find the probability up to that value there, which is up to 11 pi. So I've really got to do this integration, which of course I've done up there. So it's k over 4 sine 4x between, well, pi by 2 and 11 pi by 20. Now I'll put that sine of 4x with 11 pi by 20. I've got this horrible number here. Obviously pi by 2 gives me 0. I know what k value is as well. So I got 0.1176. That's not the answer because remember we had 4/5 here. So I think the total answer is an extra 0.8 onto that, which is 0.9176, which is what they've got. Might need to go through that. I rushed it a bit because I was running out of time, but see if you can make sense of that. It's just really finding the probability in the right section. You've got to do exercise 7e, page 134 on the textbook. Best of luck. Hope that works out.